Good. All right, so before break, as I was walking out here, I got asked the question. I said, well, what are those little funny marks beside the periodic table in your book? So in other words, take a look at this one. This right here is 178.5, 180.9, but then look at that little dagger. It's called a dagger because naturally it looks like a dagger. And in a mathematical symbol, if you see two of those little lines, it's called a double dagger. All right, but at any rate, so there's daggers. What does that mean? That means it's radioactive, which means that just particles come off of it. And I know that you guys have heard of radioactivity, all right, which is what we have here. Okay, so she asked me, well, can you tell if there's a bottle of that? Well, take a look at this. What does this say right there?
Potassium.
What?
Chloride. Potassium
chloride. Has anyone ever heard of that? We heard of sodium chloride? Where do you buy sodium chloride? At the store, right? It's in salt. Well, this potassium chloride, it's right beside it. It's called salt substitute if you got a problem with sodium, right? Like you got high blood pressure or something like that. All right. So this is a Geiger counter which detects radioactivity. So you hear it? I don't know if it's got a volume. It's got a volume. Oh. Okay, so where does that radioactivity come from? Generally from outer space. Okay, we're constantly getting hit with these radioactive things. Now let's see if it changes when you dip it down into here. Do you hear the difference? So that's radioactive. The most common form of potassium's isotope is radioactive. But it doesn't say that on here. It just is. All right? So that stuff that you can eat as food quality is radioactive. All right, now let's take a look at this. This right here says radioactive, and it's encased, which means it's safe, right? Nothing's going to jump out of that. Is that what you think? So it's coming. That's what they call a hot source. All right. Now, who's heard of the cobalt treatment, the stuff that they hit you with, cobalt 60 if you've got cancer? Tries to kill it. That's really coming out of there, isn't it? Extremely radioactive. All right. That's what they call a gamma. A gamma is the most serious type of radioactivity. All right. That is the stuff that penetrates from outer space through this concrete building. Okay. So this right here penetrates through everything. Put this up right now. Here it is in my hand. Running right through there. All right, extremely penetrate. Let's see if we can do it this way, through all this. It stopped a lot of it, right? But there's a lot of bones and fat and everything. I'm serious. And one of the ways that they do use inside nuclear reactors is water. Put a lot of reactor between you and that thing. All right, now this one here is called beta, which is not as dangerous as gamma. But you can hear that really is cranked up. All right, I mean, that's spitting out of there pretty good, right? And this is alpha. Yeah, this is alpha. You know what this is here?
Alpha.
Yeah, but take a look at that. What's that say right there?
Radioactive.
No, I know that. What's the symbol?
Oh, PO.
PO. This is polonium. All right. This is cobalt here, and this is strontium 90. All right. Now with the alpha, you can hear a little bit. All right. Has anybody got a loose sheet of paper that's not bound up? Can I see that sheet of paper really quick? Now let's see here. Will a sheet of paper stop alpha? Yeah. Somewhat, right? Nothing's perfect. But the point of the story is something thin like that will stop alpha. Now, like I've got some uranium down there. Uranium is mostly an alpha emitter, which means that something like your clothes, and that would stop it. Even though I have worked with a girl one time who she worked with it daily, and she wore a lead underwear, all right, what are called lead panties, to work on the project. But as you guys can imagine, that is not good as far as comfort goes. No one, like they make lead aprons. Again, the comfort level, I mean, we're talking pounds. And, you know, you're just kind of hunkered with that. So a lot of times we didn't wear those. Might come up to us later, but we hope not. All right, yes ma'am. Try it on you. Have you had iodine?
Huh?
Have you had iodine for your thyroid?
No.
No?
I was in the Florida room all day today.
You were in the what?
Live x-ray.
Oh yeah? I'll try it on you. I doubt it. Nothing. We'll see. I mean, one little ding could just come through the...
Maybe closer
Okay.
here because April this year.
Uh-uh. Nope. Nothing.
Particles jumping off, just hitting it, just random particles hitting it.
Hmm?
That's what makes it ding. Okay.
It's called a gamma. It's a part of an ultraviolet radiation. See, there's an electromagnetic spectrum. And you can see colors, right? You can see red, orange, yellow, green, and all that. Well, that's only a small portion. There's also, on the low energy side, radio waves. FM radio, AM radio, all that. And on the extreme high energy side, you start working into X-rays, and the most highest energy is the gamma. And that's what you're hearing right now, it's gamma. All right, the most dangerous, the highest in energy. And of course, I mean, they're coming way from outer space, somewhere made it through all of our atmosphere, all of our gases, all of this building, and it's hitting this thing right here, right? So that little packet of energy is actually came from outer space. I mean, it's the only place it could come from. Where else is it coming from, you know? So, what's that now? Used to calibrate? Well, who knows if this is calibrated right. So, yeah, who knows if this one's calibrated. Now, this is a cheapo that I got when I came here because I brought some uranium with me when I first came to FSCJ. Where's those hot sources? I thought I got them away from you ladies. I brought some uranium here, so I brought a cheap source just to use as a demonstration. Now, I mean, they make them extremely expensive, as you well know, that are digital, that tells exactly how many ions hit it within an exact amount of time, and you can do wonderful Excel spreadsheets and graphs. I mean, there's all sorts of things that can happen. So, why did I show you that? I don't know. Something neat, right? I mean, you've got these atoms. They are spitting off particles, and that's what these things right here mean. All right? Now, how are we doing? Radon's one of them. Yeah, radon gas is very dangerous. That's here number 86. And how that's produced is by it's a series of nuclear reactions where you can take uranium in the ground and that decays to form radon, which is a gas. Okay. Now, I know we haven't talked about atomic masses yet, but let's look at nitrogen. How much does that weigh? 14. Okay. Nitrogen 14.0067. Radon weighs 222. So which one's heavier? Radon. And this is the thing that's radioactive. Okay? So it's a good idea to have your homes checked for it. When I was a senior working on my chemistry degree, that was my senior project, was to find out a way and to test for radon. Okay? So we had these little containers that basically were like a charcoal type container. You went out and you put in someone's house in their basement for like a week. And it would gather all this. And then you would take it to like a real Geiger counter like he's talking about. And you would sit there and let it count, and it would tell you the concentration of radon in the home. Why is that important? This is radioactive. So when that gas gets inside your lungs, it's heavy. Now that stuff coming off of there, that's not good for you. It is not a safe thing. Now, me touching it is not going to be a problem. But like you wouldn't want to sleep with that underneath your pillow with a constant bombardment of radiation. I could pass this around right now. Everybody could touch it, no problems. But you wouldn't want to sleep with it there 24 hours a day, 7 days a week for 30 years. You would develop cancer for sure. All right? The same thing happens with this radon. It gets in your lungs, and especially if you don't work out, anything like that, it sets at the bottom lobes, and it creates radioactivity. Over the course of 30 years, the increased rate of lung cancer is tremendous. So what can you do? Well, if your home has it, it depends on its concentration. Some measures are as simple as just opening up the windows in your basement and just let the ventilation and the air, just the natural wind, carry it out periodically. There are companies you can call who actually put a sealant